Talk about linear inequalities. So linear, it's a line. Inequality, they're not equal. So first we're going to look at this example where y is less than or equal to negative 3x plus 3. Less than or equal to, just like before, that means it includes the line. Before it included the number, now it includes the line. So I'm going to go ahead and draw this line. It's negative 3x plus 3. So that's slope-intercept form. That means my intercept is, that wasn't a very good dot, at 3. And I'm going to go down 3 over 1, down 3 over 1, down 3 over 1. And I'm going to go ahead and graph that line. And it will look something like this. And what I really want to look at is what does it mean for y to be less than or equal to that line? So where is it less than? So let's look at x equals 3. When x is 3, y is 5, almost. Actually, it's 6. So when x is 3, y is 6. Negative 6, and I want a number smaller than negative 6, which would be negative 7. So negative 7 is less than or equal to negative 3 times 3 plus 3. Well, that's negative 9 plus 3, which is negative 6, and negative 7 is indeed less than. So I am going to then highlight everything underneath on this side of the line, because this is where y is less than negative 3x plus 3. Let's look at another problem just to see if we can kind of solidify that some more. What if I have y is less than or equal to 2x minus 1? Well, my y-intercept is going to be negative 1. And my slope is going to be 2, so that would be up 2 over 1, up 2 over 1, up 2 over 1, and I'm going to draw that line again. It includes the line, so it's going to look something along those lines. And now, again, I want to find where y is less than that, 2x minus 1. So if I pick x is 2, if I look at x is 2, then y is 3, and I want to be less than that, so I want to pick perhaps 2. So let's look at another one. If I look at 4, when x is 4, y is 7, and something less than 7 would be 6, so I want to come on this side of the line now. What if I look at y is less than 1? So now I no longer have less than or equal to, I have just less than. On the number line, we would use an open circle. So here, we're going to use a dashed line. So I would have dashes along y equals 1. And then where would y be less than 1? Well, anything down here. So this is what the graph of y is less than 1 looks like. We're going to try a few more problems. 2x is less than or equal to negative 2. Well, first I need to get that looking like slope-intercept, so I'm going to add 2x to both sides. And I get y is less than or equal to 2x minus 2. That's 2. And so my slope-intercept form there, that means my intercept is negative 2. And my slope is going to be positive 2, so that's up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And that means that my line is going to look something like this. And again, I want to find where y is less than 2x minus 2. So let's choose x is 4. When x is 4, y is 6. So when x is 4, y is 6. And I want to pick a y that's less than. So I could pick 5 right here. If I looked at x is 6, at 6, y is going to be 10, and I want something less than that. So I could look down here at 8. So for this one, my highlighting would be over here. Let's try another problem. What if I have x plus 2y is greater than 6? So x plus 2y is greater than 6. First thing I want to do is make it look like slope-intercept. So I'm going to have 2y is greater than negative x plus 6. And then I need to divide everything by 2. So y is greater than negative 1/2 x plus 3. And I want to graph that. So first things first, slope-intercept. My intercept is going to be positive 3. And my slope is going to be negative 1/2. So that means I can go down 1 and to the right 2, down 1 and to the right 2, or I could go up 1 and to the left 2, up 1 and to the left 2. And so that line is going to look roughly like that. And let's pick an x. If x is 2, y is going to be 2. So when x is 2, y is 2, but I want y to be greater than, so I want to look somewhere like at 3. So I want y to be 3. So that means that my graph, I would highlight above the line, above and to the right. Excellent. But we have one slight problem. I say greater than, greater than. So that means that this needs to be a dashed line because it does not include the line. So all I have to do is make it a dashed line to make sure that I'm not including it when I'm doing less than or greater than. We're going to do one more problem in our last video. We're going to look at y greater than 2/3 x minus 2. I took the liberty of making sure that our problem was already in slope-intercept form, so we wouldn't have to worry about that. So y greater than 2/3 x minus 2, well, my intercept is going to be at negative 2, and my slope is going to be 2/3, so I'm going to positive, so that's up 2 over 3, up 2 over 3, up 2 over 3, and it's greater than. It does not say greater than or equal to, so I'm going to have a dashed line going through here, and I want to look and see about a couple points. So I want y to be greater than. So if we look at, for instance, let's look at x is 6. Well, we said x is 6, y is 2, right there, and I want to be greater than, so I'm going to be something above 2, which would be 3, and that would mean that I would want to highlight everything above y is greater than 2x. So when graphing a linear inequality, I have a couple things to keep in mind. If it's less than or equal to or greater than or equal to, it's a solid line. If it's less than or greater than, it's a dashed line. And then I highlight the area with the correct y values. So that's how you're going to do the linear inequalities. And the moment you've all been waiting for, I do indeed have a math joke for you. How many seconds are in a year? How many seconds in a year? I'm going to give you a minute to ponder that. So it's 60 seconds in a minute, 60 minutes in an hour, 24 hours a day, 356 days, which equals 12 seconds. You got January 2nd, February 2nd, March 2nd. Get it? There are 12 seconds, like the second of each month, and there are 12 months in a year. Hee hee. Alright, enjoy. Later. See you tomorrow.